Hey everyone, we are here to present a project titled Zero Click Defender, a hybrid pre-click malicious URL detection framework for web browsers. I am Sandhya along with my teammates Nitish and Sarlin Sajal under the guidance of Dr. P. Vinodya Lakshmi ma'am. Today we will explain the problem of phishing attacks, limitations of existing systems, our proposed hybrid framework, system architecture and modules, implementation and results. So the abstract is in today's digital world, phishing attacks have become one of the most dangerous cyber threats. Attackers no longer rely only on fake emails. They now use social media, SMS links, fake domains, and URL obfuscation techniques to steal sensitive user information. Most of the traditional phishing detection systems are reactive. That means they identify threats only after the user clicks the malicious. Our project Zero Click Defender changes this approach from post click detection to pre click protection. The key idea is instead of waiting for the user to open the malicious web page, our system analyzes the URL during the hover stage itself. The framework uses a hybrid architecture, client side detection for speed and privacy, cloud side verification for uncertain cases. The technologies used include SHA-256 prefix hash lookup, heuristic and regex analysis, light GBM machine learning model, AWS cloud verification. So, our problem statement, let us discuss the problems in existing phishing defense systems. Modern cyber Modern cybersecurity systems face several major challenges. In that reactive nature, most systems warn users only after they open the malicious website. By that time, credentials may already be stolen. High latency. Cloud-based solutions send every URL to remote servers for analysis. This introduces delays and slows down browsing. The next is zero-day attacks. Traditional blacklist systems cannot detect newly created phishing websites because they are not yet stored in databases. Privacy issues. Sending user browsing data to third party servers raising serious privacy concerns. The last is lack of user awareness. Warning messages are often too late or too subtle, causing users to accidentally interact with malicious links. Because of these issues, there is a need for a proactive, privacy focused, and real time phishing detection system. So, the next is introduction to basic concepts. In this, phishing is a social engineering attacks where cyber criminals impersonate trusted organizations such as banks, e-commerce, websites, or social media platforms to steal passwords, OTPs, and financial information. Over time, phishing attacks have evolved significantly. Attackers now use smishing through SMS, social media scams, short-ended malicious URLs, domain spoofing, homograph attacks using visually similar characters. Traditional deduction techniques include blacklist-based deduction, fast but ineffective against new threats. Heuristic analysis, it checks suspicious URL patterns and structures. Machine learning, it learns phishing characteristics from datasets and predicts malicious behavior. So the next is a literature review. We studied several recent research papers before designing our system. So the paper one is Flush Hunter XLD. This research combined deep learning and machine learning models for phishing URL classification and achieved high accuracy. From this paper, we adopted the idea of hybrid detection. So the next is paper 2 is prime framework. This paper introduces dual validation system using quantitative and fuzzy logic analysis. This inspired are multi-layer decision pipeline where uncertain URLs are sent for deeper analysis. The next paper 3 is early stage detection. This research focused on detecting attacks before user interaction. It validated our pre-click philosophy. Paper 4 is multi-channel deduction. This paper used URL, HTML, and metadata simultaneously. This inspired our infrastructure and metadata verification approach using SSL and Whois information. The next is issues and challenges. So during development, several challenges are identified. Deep learning models are too heavy for browser execution. Existing systems mainly focus on post-click deduction. There is always a trade-off between speed and accuracy. Browser extension require lightweight real-time processing. Block list cannot immediately detect newly generated phishing domains. Cloud-only system increase latency and reduce privacy. These challenges motivated us to design a lightweight hybrid system capable of real-time protection. So the next is proposed work. Let us discuss our proposed system. The goal of Zero Click Defender is to stop phishing attacks before the user clicks the link. The workflow contains five major phases. The phase one is hover deduction. The browser extension continuously monitors mouse events. When the cursor hovers over a link, the system captures the target URL instantly. Since this happens before clicking, the system acts as a preventive security layer. The phase 2 is URL normalization and feature extraction. The captured URL is cleaned and standardized. The process includes converting to lowercase, removing www, extracting structural features. The feature analyzed includes URL length, number of subdomains, digit and symbol ratios, presence of IP addresses, entropy score indicating randomness. These features help identify suspicious pattern. The phase 3 is client-side analysis. This is the main defense layer. So prefix hash lookup. The URL is hashed using SHA-256. Only hash prefixes are checked against a local malicious database to preserve privacy. Heuristic and regex engine. This module detects sensitive keywords like login or verify, encoded malicious patterns, Unicode homograph attacks, raw IP-based URLs. Machine learning using LightGBM. A lightweight LightGBM model performs local inference using ONNX runtime. It generates a risk score between 0 and 100. Selective cloud verification. If the browser cannot confidently classify the URL, it is sent to the cloud for deeper verification. We use AWS Lambda for serverless backend analysis. The cloud checks include SSL certificate validation, domain registration age, infrastructure metadata. Only a very small percentage of suspicious URLs are sent to the cloud, maintaining both speed and privacy. The final verdict is after analysis, the system provides a simple visual attack to the user. Safe URLs show a green indication, suspicious URLs show warning alerts. This user to avoid interacting with malicious websites before opening them. The next is system architecture. So the architecture contains both client-side and cloud-side modules. The browser extension performs URL capture, feature extraction, hash lookup, heuristic checks, machine learning inference. The cloud layer performs advanced infrastructure verification when needed. This hybrid design ensures faster response, better scalability, reduced network usage, enhanced privacy protection. So the next system requirements. So these are all the tools and technologies that we use in our project. Next is modules and its description. So module 1 is hover deduction and normalization. This module continuously monitors the mouse hover events in real time. Whenever the user places the cursor over a URL, the system captures that link. Module 2, prefix hash lookup. Instead of storing complete malicious URLs, the system generates the SHA-256 hash of the domain. Then only the first few characters called the prefix are checked against the local database of phishing hashes. Module 3, Heuristic and Regex module. This module uses rule-based analysis to identify suspicious URL structures. Module 4, Light GBM Machine Learning module. This is the core intelligent module of the system. It uses a Light GBM machine learning model to analyze around 14 URL features such as URL length, randomness score, number of digits, and symbols, entropy score. Module 5, Cloud verification and user alert. If the local system is not fully confident, the URL is checked using cloud-based verification. The cloud checks domain age, SSL certificate validity, reputation data. Finally, the result is shown to the user through a warning or tooltip. The next is implementation. We successfully implemented the browser extension and tested it using phishing URL datasets. The screenshot shown demonstrate URL hover deduction, real-time analysis, risk scoring, user warning notification. The system operates efficiently inside the browser with minimal delay. So to conclude, Zero Click Defender provides a proactive and privacy preserving solution against phishing attacks. The project successfully combines real-time browser monitoring, hybrid deduction architecture, lightweight machine learning, cloud verification. Our system achieved high accuracy while maintaining extremely low latency. Most importantly, it protects user before they interact with malicious link. In the future, the system can be extended with deep learning enhancement, mobile browser integration, real-time threat intelligence update, multilingual phishing reduction. Thank you, everyone.